So in this lesson, we're going to take a look at similarity proofs. Now, I think we did a similarity proof in the last lesson, but we're really going to be talking about them all throughout this lesson. So let's take a look at exercise 1. Now, actually, before we do that, remember our three main criteria or theorems for proving two triangles are similar are angle, similarity. So two angles are congruent of similar triangles. Our second one is side similarity. So all three sides are proportional. And our third one, our side angle side similarity. So two sides are proportional and the included angle is pair are congruent. Okay. So let's go back to exercise 1. So let's take a look at it. In the diagram shown, BD and AE are drawn and intersect at C. It is also known that AB is parallel to DE. We want to prove that triangle ABC is similar to triangle EDC. Now we're going to set it up like we do with our congruent proofs. So we're going to have our statements, and we are going to have our reasons. Okay. So we were given that BD and AE are drawn and intersect at C, and we are also given AB is parallel to DE. So this is going to be an important part of this proof. Okay. Now, I think I mentioned this, maybe not in the last lesson, I don't know, but most of the time, the more common theorem or more common way we prove two triangles are similar is by angle similarity. So I encourage you to always look for two congruent angles before you try to go proving these two. So always start with this one, see if you can prove it this way first, then see if you have to prove it these two ways, either one of these two ways, okay? So now we are given that these two lines are parallel. So AB is parallel to DE. So remember, when we have parallel lines, we either are going to have some corresponding angles or we're going to have some alternate interior angles, okay? So I am going to say that angle A is congruent to angle E. And this is because if two lines are parallel, then alternate interior angles are congruent. Now we also have another pair of parallel alternate interior angles, this one and this one. So angle B is congruent to angle D. So if two lines are parallel, then alternate interior angles are congruent. Okay, so that gives me, I have a congruent angle here and I have a congruent angle here. So now I have two congruent angles, so now I can say these triangles are similar. So triangle ABC is similar to triangle EDC. So this is by angle similarity. Okay. All right, so let's look at exercise 2. So in the diagram shown, MN is congruent to MP. So this side is congruent to this side. So meaning triangle MNP is isosceles. And points R, S, T, and W all lie on the sides of triangle MNP such that RT is perpendicular to NP and SW is perpendicular to NP. Okay, so now our first part is we want to explain why triangle NTR must be similar to triangle PWS. So they don't necessarily ask us to prove, but they just ask us to explain. But we're going to go kind of through that same process like we did in the above one with this one, all right? Now, since we were given that MN is congruent to MP, so this is an isosceles triangle. We know that the base angles of an isosceles triangle are congruent. So we know that angle N is congruent to angle P. Okay. So we're trying to prove these two triangles similar. Now we're also given that RT is perpendicular to NP and SW is perpendicular to NP. So this angle and this angle are right angles, all right? And then, so since RT is perpendicular to NP and is perpendicular to NP, angle NTS and angle PWS, no, NTR, excuse me, and PWS are right angles. Okay. Thus, angle NTR would be congruent to angle PWS. Okay. So since I lied. So since we have an angle here, a congruent angle pair here, by angle similarity, triangle NTR is similar to triangle PWS. All right, so let's take a look at B. So if RT is equal to 12, PW is equal to 3, and SW is equal to NT, then we're going to solve for the length of SW. So NT is equal to the length of SW. Now, when we do these proportion things, we are going to, it helps tremendously if we redraw them without a whole bunch of stuff and in the same orientation, so we can see what sides correspond to which sides. Now you guys are looking at this probably, maybe these are right angles, so I can use Pythagorean theorem. No. Okay, these are similar triangles, and I want you to kind of maybe start getting in the habit of thinking about when we have similar triangles, possibly the best way to solve for the missing side is to set up and solve a proportion. Now, if we knew at least one more side in each of these triangles, maybe we could do Pythagorean theorem to find the third side in one of the triangles. But when we have similar triangles here, we are setting up and solving proportions. Okay? So now we are looking for the length of SW. Now NT is the same, these are the same length, so we're also going to call this X. Okay. Now, one way that we can set up and solve a proportion is RT over SW is equal to TN over PW. So now I'm just going to plug in my numbers here into this. So RT is 12, so I'm going to do 12 over X is equal to X over 3. Okay. So now I'm going to cross multiply. So 3 times 12 is 36 is equal to X squared. Now I'm going to take the square root, so 6 is equal to X. So SW is equal to 6. So let's take a look at the next page. All right, so at the top it just says there are occasions where reasoning other than angle will occur. It's rare, and we should always consider whether you can prove two angle pairs equal. So just like I said at the beginning of the lesson, but let's take a look at an example where it doesn't involve angle similarity. Okay, so in the diagram shown, midpoints of sides AE and AD have been marked as C and B and connected to form segment BC. So we were told that B and C are the midpoints. Okay, that's important. Now, the first part, they want us to draw a sketch of triangle ABC and ADE separately below. Now, as I've mentioned probably many times now, it's helpful to redraw the diagrams when they're together like this. Okay? Now, between these two, what angle must be congruent between the two triangles? So we know that angle A is in both of the triangles. So by reflexive, angle A can be congruent to angle A. Now, why do we want to use side angle side to justify that these two triangles are similar? Well, since C is the midpoint of AE and B is the midpoint of AD, the length of AE is equal to twice the length of AC, and AD is equal to twice the length of AB. So because of this, AD over AB is equal to AE over AC. So since we have two sides that are proportional, we have two sides proportional and an included angle, we can use side angle side similarity. So now we were told that these two triangles are similar. All right, so let's keep that in mind. Or we weren't told that, we just proved that. Okay, so that these two triangles are similar. So I want you guys to keep that in mind for letter D. So let's take a look at letter D. So why must angle EDA be congruent to angle CBA? So why must EDA be congruent to CBA? So these are corresponding angles, and we know in corresponding angles in similar triangles, corresponding angles are congruent. So since angle EDA and angle CBA are corresponding angles of similar triangles, they are congruent. Now, since these are corresponding angles, since corresponding are congruent, that can help us prove that ED is parallel to CB. And I bet most of you wanted to say that because these two are parallel, these two are congruent. No, be careful. We can't assume things, right? We know that these two triangles are similar. So since these two triangles are similar, corresponding angles are congruent. Since corresponding angles are congruent, that proves that these two lines are parallel. Okay? So now let's look at the last exercise in this lesson. In the diagram below, parallelogram ABCD has point P located on side CD. Segments AP and BC are extended to point M where they intersect. Now we have to give an argument for why triangle MCP, this one, is similar to both triangle ADP, this one, and MBA, this whole thing. Okay? Now we were given that parallelogram ABCD is a parallelogram, and we know that the opposite sides of a parallelogram are parallel. So because they're parallel, somewhere in here we're going to have some alternate interior angles. Okay? So now let's talk about why triangle MCP is similar to triangle ADP. Okay? Now, like we said, since AD is parallel to BM, I'm going to use numbers. This angle and this angle are going to be alternate interior angles. Angle 1 is congruent to angle 2 because if two lines are parallel, then alternate interior angles are congruent. Okay. Now, this angle and this angle, as we know, are vertical angles. So now we can say that angle CPM is congruent to angle APD because vertical angles are congruent. Okay. So by angle similarity, triangle MCP is similar to triangle ADP. All right? So it's kind of the same thing with these two triangles, with triangle MCP and MBA. All right, so now let's talk about those. All right, so now let's look at that. So we know that, or we can tell that angle M is part of both MCP and MBA. So by reflexive, so angle M is congruent to angle M by reflexive property. Now, again, let's go back to the fact that ABCD is a parallelogram. We know that CD is parallel to AB. So we know that this angle is congruent to this angle, and we know that this angle is congruent to that angle by corresponding, because they're corresponding angles, because these two lines are parallel. Now, we only need one of these angles because we already know that angle M is congruent to angle M. So let's say that angle MCP is congruent to angle, actually I lied. Let's say this first. So since CD is parallel to AB, angle MCP is congruent to angle MBA, because if two lines are parallel, then corresponding angles are congruent. So again, by angle, similarity, triangle MCP is similar to triangle MBA.